So hi guys. Today I'm just gonna talk about what I learned today. Um, I read this research paper which is called MapReduce Simplified Data Processing on Large Clusters. I only read like third page of it, but still, so I'm just gonna try my best to explain. Why do we have this? What is the MapReduce and what is kind of is important and ex- the key concept of while reading this kind of research paper. Australians don't know the a map reduce is just the like it like just saying it's just saying here. So map reduce is a program model and associated implementation for processing generating large data sets. Um, but I understand that this concept is kind of very abstract, um, because the so like just me, I just read this kind of this part processing model and associated implementation of processing and generating large data set. Uh, so when I first encountered the process model and this processing and generating large data set just kind of lead into just led me to into fall into a rabbit hole that I thought the map reduce is just kind of the thing in the JavaScript, because in the JavaScript there's a array map and array.js, and when this talks about map reduce, but talking about like process programming model and processing and generating large data set, I just uh, I just didn't get it. So let's read next thing. The user specify a map function that process a key value pair to generate set of intermediate key value pair, and the reduce function that merges intermediate values associated with the same intermediate key. And I think this sentence is just basically explaining the what is map and reduce functions. Um, So why do here map function that process a key value pair generate a set of intermediate key value. Um, this sentence is kind of really hard to understand. So let me just elaborate this more. When we think about the map, if you're like front engineer, you have an experience of map, which is it's just kind of there's a bunch of array. There's a bunch of element in the array, example 2, 1, 3, and 4. And when we're trying to use map function, we can change these elements into element value into some kind of other syntax. Example, let's say we wanna do map that our our sorry our value has to be increased by 1, and this result is going to be 3, 2, 4, 5. So basically the map from map is some kind of function that transform the original data into some kind of the new data. The reason why it's saying the key value pairs um, is just because it's just the some kind of way to describe the some kind of data set. Let's just think about the metadata. Example, let's say this 2 is some kind of so metadata of whatever thing. So so that's gonna be key value of, because since this is metadata, we have to really make it parse it and easy to understand. So 2 is transformed into metadata, which is key value pairs, and even 1 in 2 and 1 and 3 or 4 is some kind of the data set that represent as a key value. Just think about the metadata of the some kind of some kind of whatever um, some kind of like table of contents. There's gonna be a bunch of the metadata. Just treat it as a, like those kind of thing. Next thing is an intermediate thing. So, and it just meaning of this map function, based on the intermediate is after the math function isn't really done. You have to use this kind of key value on data set and just transform into new data sets that the user wants. So map function is basically generating some kind of middle level of the key value pairs. After that, you can manipulate it from the reduce functions. So basically, it's just the making the original data set into some kind of key value pairs, like metadata, but it isn't done. So this kind of like the intermediate middle level of it, and next part is gonna be using a reduce function to do whatever things for the data set. A reduce functions is the merges or the intermediate values associated with the same intermediate key. So basically, what it does is it merges the intermediate values also with the same intermediate key. So I just said about this kind of data set, right? And it merges and it do the computation, and it will eventually give the answers that we want. So, but why do we have to use map reduce? Because sometimes if there's a lot of uh, uh, input data, we have to make it as a we have to parallelize computation of it, and this map reduce, based on the map reduce, we can just doesn't have to think about those kind of under the hood, because map reduce doing doing this kind of parallelize the computation of the input data is handled by the map reduce, so we don't have to think about the what's going to be under the hood. So map reduce is doing those kind of automatically. So that's and next, yeah. So this kind of part is the explanation of what I just said. It doing automatically. So the other thing you can also consider is the parallel and distributed system. Rather than using a really expensive server, example, expensive server, you can just use some kind of server, the cheap server, for the instead of using it. But since this, of course, the computation is kind of bad, because this is more better, because hardware spec is much better than other 10 or $100 of it. So what it does is, why don't we use the parallelize this kind of computation, but we use the if to solve this kind of the input data, the mass input data, we can just use the map reduce function to compute this input data, but with the parallelism. So we don't have to use some kind of expensive server. So that's kind of really the good thing about map reduce thing. How can I delete? So, and this introductions explains a lot, and this part is saying that the issue of how to parallelize the computation, distribute the data, and handle failure conspire to obscure the original simple computation with large amounts of complex code to deal with these issues. And to solve this kind of issue, there's a map reduce logic of it. So basically, a map reduce, and it explains a lot on why we have to use about map reduce and those kind of things. And it also talk about map operation and its logical record in our input in order to compute a set of intermediate key pairs, and that is already explains on this part here. It's simple, and so we can just do a chip, just the normal chip commodity pieces, rather than buying it the really expensive computers. So that's also written here. Oh, I scroll a lot. So that is kind of a difference of so there's kind of a explanation of MapReduce. In the introduction part, it clearly explains why we have to use the MapReduce function and what is important. Also, and while I'm reading this kind of book, this kind of research paper, actually this is a research paper, I wrote the question of it here. My general approach while reading this research paper was how can I utilize it. I'm a front-end engineer, or like the web part, and actually front-end engineer doesn't use kind of MapReduce logic. I think the server engineer is gonna be using it, but I don't know. So my question is, why don't we why is this going? Why don't we use why don't we make some kind of crawler but use a cheap server, but for the computation using MapReduce. So we can just make some kind of the crawler bot, because basically we are actually very small start, not even start, we are really small. Our there's only like 3 people in our to make our service. The problem is that it's really kind of hard to find the user likes our product. And so our service is basically AI tutor coding education platform, but we were not sure that people will like this kind of AI tutor thing, and we don't know how many AI tutor services are out of this world. So my general approach was, why don't we make some kind of crawler to get some kind of web page or website or metadata talks about AI tutor and checks if there's other service and if there's other competitor for it. But since there's only a lack of money, why don't we use the cheap server by using this MapReduce functions to increase the high performance by using the community pieces rather than using the high expensive pieces. So that was my imagination while reading this research paper. Tomorrow I'm just gonna read this a lot. I read till here too. Wait, I read almost this part or so. I have to read this kind of diagram. How does it do? But rather than that, I read till the page 4. No, page 3. Yeah, page 3 here. So have a nice day. See you next time. Bye bye.